All right, hello. So we're about to start Module 4, which is all about defining functions. A lot of students tend to struggle when they're getting started with writing functions. I wanted to put together some live coding examples of me going through and authoring some code involving functions. I've got about 7 questions here that I'm going to put myself through, and for each one of them, I'm going to need to define some functions and write some tests. Now, at this point, you may not know too much of what I'm talking about, but if you sit through and watch the videos, get something from them, then you move on to the other lessons, they'll probably explain a lot of what you saw. So you might want to watch this, go through the lessons, and then come back and watch this again, and it should all make a lot more sense. And as you go through the questions, you might refer back to some of these. So I'm just going to get started. My first question here, you have a bunch of bunnies sitting in a row, and you want to know how many ears they have. As we all know, bunnies have 2 big ears. Define a function count bunny ears that consumes the number of bunnies and produces the number of ears. So really, we just need to double the number of bunnies. Now, whenever we get started with a question like this, we're going to need to unit test it before we're done. Now that requires us to have the unit testing function, assert equal, which we get from the Sys108 library. And typically I will just give you this code. I happen to know the exact line of code I need. So I'll have assert equal, and I'll be able to use that to write my unit tests. Eventually I'm going to end up having my count bunny ears function. That's what they want me to define. If I had the count bunny ears function, I'd be able to call it and say things like, oh, I've got 5 bunnies. And I would anticipate that if I called this, say down in the shell, it would produce the value 10. Currently, of course, I haven't actually defined it, so I end up with a name error if I try and call it. It is frequently helpful, however, to think about what you want the function to do before you write it. So I'm going to write some unit tests based on the function that I haven't even defined yet. So count bunny ears, when I call it with 5, should produce 10. If I have 5 bunnies, they have 10 ears. Think of a few more cases. We have 1 bunny, they've got 2 ears. If I have 0 bunnies, they have 0 ears. It's a good starting point, 3 test cases. Now, once I've gotten them, if I try and run the program, it won't work. It's going to be a name error because I still have not defined the count bunny ears. Let me just get this guy out of the way so he stops interrupting. Now, let's go ahead and start actually defining the function. I'm going to need to begin with a def, define, and the name of the function up here, count bunny ears. Could type that out. I can start off with the core template. It's always going to have parentheses, a colon, and pass. I have to figure out if I need any parameters. Now, they say up here that it consumes the number of bunnies, so I know it's going to need the number of bunnies. I could call it number of bunnies, or perhaps more briefly, just bunnies. That will be a number. Specifically, it'll be an integer. We don't want to talk about half a bunny. That's a bit gruesome. The function produces the number of ears. Again, we don't want to talk about half an ear, so we'll talk about an integer being the result. This is how we say that it will produce an integer. Now, just from this, all I've really done, I haven't really thought a whole lot. I've read a little bit. I've written some unit tests to think about what the output is, but I haven't actually written the body of the function at all. So that's still pretty early in this process. This is the usual way of going about this. At this point, I can actually think about what it should do. Number of ears is the thing I'm trying to calculate and return, so I'll start with the end. The end point of this, I need to have the number of ears. Perhaps just ears would be shorter. I have bunnies, and I said out loud, if I have bunnies, I just double the number of bunnies, and that's how many ears I need. So I'll say that ears is the result of bunnies times 2. I've written some code. I can find out if it works by running the code, and that runs my assert equals. You see that they all came out successful. So that's great. That means I finished my first question. Let's go on to the next one. Question 2. Define a function divide that consumes 2 integers and divides them together, producing a float. So this is again just some simple basic math, more direct this time. I'll need my library, so I'll import assert equal, and then I'll think about some unit tests. If we call divide on, say, 1 and 2, that should produce the float 0.5. See, I just copied those 2 lines, and if I do 2 divided by 1, it should produce 2.0. Notice it's a float. And what about, 5 and 10, something more interesting? That would also produce 0.5. Got my tests. I can give the header of my function, begin with def, the name of the function, consumes 2 integers. We'll call them first and second with the appropriate types, produces a float, so we'll say it produces a float. And now we're ready to actually start writing the code. Now we can actually start thinking how to go about doing division. Well, we know that we want to return something, and the thing we want to return is the result of dividing the first by the second. So we could just type that in directly. We could also have captured that result, stored it in a variable, and used the variable. Could have gone either way. Let's see if I got it right. Once again, I am successful. So I managed to pass all my test cases, ready to move on. This next one has 2 parts. Question 3a, write a function, 2 decimal places, that consumes a float value and produces that value rounded to 2 decimal places. Well, it turns out that Python has a built-in function called round that will help do this for me. So my version of 2 decimal places will be pretty simple. I'm going to end up having a function that consumes a float value, a value that is of type float, produces another float. Let me just show you what I mean with this by writing a unit test. I need to always remember to import my library unless it does it for me. 2 decimal places. It takes in something like, say, 5.256 and would produce 5.25. Or if I gave it 1.001, it would produce just 1.0. Or even thinking outside the box, if I had negative 5.0, it would leave it as negative 5.0 because there's nothing past the second decimal place. Okay. I know how the round function works. If you Google for Python round, you can look up the documentation, you can read it, and you'd find out that you can call the round function by calling round, passing in a float value, and a second parameter, which is the number of places. So here I've done 2 places, so when I round it, should pass those unit tests. Oh, got something not quite right. So here I'm rounding to 2 places instead of just truncating. And the spec is a little vague about what it wants me to do. It does say round, whether it wants me to round down or up, it's not precise. But we'll need to, in this case, adjust our test case to match what we want. So we'll say it should be 5.26. Now, what if we wanted to truncate? We would have to do something different instead of rounding. And that's relevant to part 2 of this question. Question 3b has us do it again without the built-in round function. Now, the nice thing here is we can go take all of our existing code and copy it. We don't need to import the assert equal twice. Only have to do that once. And we'll need to rename 2 decimal places so we don't clobber the old one. We'll call it without round. Use that down here in the same way. This time we're not going to use round, and we're going to try and aim to truncate instead of round. So 5.256 will become 5.25. But otherwise, we'll treat this unchanged. Now, in this version, we're going to have a different body. We're going to do something different in order to solve it. There's various ways to go about this. Now, my strategy, the idea that I would cook up for this, is if I multiply the number by 100, that moves it 2 decimal places to the left, so 5.256 would become 525.6. Then I turn it to an integer, or I round it, whichever. But if I turn it to an integer, because I'm not allowed to use a round function, that would chop off the decimal, and I could divide by 100 to get the result. So let's break down each of those steps as comments first. So just to make notes to myself, we're going to have over here multiply by 100. I'm going to turn to an integer, divide by 100, return result. So this is me sort of sketching out how I want to go about thinking about this. Writing some pseudocode is often very helpful. Then I'm going to turn each line into real Python code. So first, I take the old value and turn it into 100 bigger by multiplying by 100. Then I'll turn it into an integer by calling the built-in int function, which converts floats to integers by chopping off the decimal place. I could look this up in the documentation to find it. I have my integer. I want to divide it by 100 and store it somewhere else. So back to the original number of places. And then I'll return that result. You can see if I got this right. Aha! So I'm now passing all of my test cases with both attempts, both styles. So you see that there was a solution there. Moving along. Next up, we're doing swap first two letters. Define this function, consumes a string, produces a new string with the first two letters swapped. So we're going to need our sys108 assert equal function. We're going to think about what this looks like in terms of results. Swap first two letters. We give it a string like, say, hello, and that would produce the HLLO. We don't have to worry about the capitalization. Copy and paste that line. Think of another interesting test case. What if we just had 0, 1? That would turn into 10. And one more, we'll take dad and turn it into add. The function doesn't tell us what to do if we have less than 2 characters, so we won't worry about that case. If the instructions don't say to handle it, we don't have to handle it. Later on, we will make sure that we do handle such kinds of interesting situations, but not for this question. Now we can start working on the header. We take the name of the function, the def keyword. We need to have it consume a string and do something. We know it's going to be of type string. We know it's going to produce a string based on the instruction, consumes a string, produces a new string. We need to start breaking apart the string, which we learned how to do last week. So we'll take the first character out of it. We'll get the second character out of it. Once we have the first and the second characters, we can swap their order. But we still need the rest of the characters. So we got the first, we got the second. Now we're going to get all the other characters after that using string indexing. And then finally, we can recombine all of them with the swapped plus the rest and return the recombined version. Let's see if I got that right. Cool, passed all 3 of my test cases. Let's move on to another one. This one speaks to some of my childhood. When I was a kid, there was this show where they start off with the na-na-na-na-na-na Batman, and I want to try and recreate that with this introduce Batman function. Consumes a length, which is an integer. That's going to be the number of times I say nah. And they got this tricky part here. They want me to capitalize the first nah, and then I'll have Batman at the end. So I'm going to need my sys108 library. I can write some test cases to show off what I want. So introduce Batman. Introduce Batman will be a function. It consumes a integer, like for instance 1. And when you do that, it's going to produce nah Batman, all caps. Copy and paste this line. If we had 2, it would do nah Batman. But usually in the show, they would have a bunch of them. So it'd be like nah Batman. Na Batman. Cool. So those are my test cases. Let's write out the header of the function. Introduce Batman consumes a length, which is an int, and produces a string. In terms of what we need to do, first we need to get that initial capital nah. So it always begins with a nah. We assume that length is always going to be 1 or greater. If we have done that, that shouldn't count towards the first nah, right? So over here with 2, the lowercase nahs, we're going to be only counting, there's only 1 of them. So we're going to decrement length by 1. Then we'll say the rest of the nas are going to be done via string multiplication, na times length. We'll have the final part where we say Batman, and we can return the first plus the rest of the nas plus the final part. Okay? If we did everything right, then we should be able to produce those strings, and it looks like we did. Okay. So this video is getting a little bit long. I had 2 other functions planned out. I'm going to briefly go through them very quickly. From sys108, import assert equal. This one's actually a little bit interesting. It's going to take advantage of the fact that we can use the built-in ord and char functions. When we use these, they turn strings into numbers and numbers into strings. So each string, each individual character, I should say, maps to a unique number. The letter A maps to 65, B maps to 66. Matters if it's lowercase or uppercase. Lowercase a is 97, lowercase b is 98. All characters get this kind of treatment. The string 1 maps to the number 49, and same thing with like all the symbols and stuff. We're going to use that to make a rotate function that takes a string, converts it to a number, adds 1, converts it back using the char function, and allows us to sort of rotate things. So A becomes B, B becomes C, and so on. Let's make up a quick example. Rotate 1 has A becomes B, and we said that lowercase a will become lowercase b, and we can say that S becomes T, 1 becomes 2. It turns out that if you do ord of 9, it's 57. If you increment that, check the next number, it's going to be a colon. So we'll say that 9 becomes colon. It's pretty weird. Let's start writing the function. I've broken down a little bit about it. We've got rotate 1 consumes a character, so it should be a char character, which is of type string. It's supposed to only be length 1, and produces a new string, which should only be of length 1, but we'll just say it's a string for now. We've got a few steps. First, we need to get it as a number by using the ord. Then we need to increase that number by 1. And then we need to convert it back to a character by using char. And finally, we can return that modified character. And if I did everything right, we have this handy little function, which we seem to do. So I can take rotate 1, I can use that later in my program, right? I defined this function for a reason. I can use this to find out what each of the letters' next characters are in the alphabet. R goes to S, and 8 goes to 9, or open parentheses goes to close parentheses. So that's pretty cool. The next function that we're going to do builds off this one. It's the same idea, except we're going to add an integer argument indicating the amount to rotate by. So previously, we always added 1, but now we're going to rotate by an amount. That amount will be an integer. We can just modify some of our old code. We're probably going to want to add a lot more cases, though, because it's a more interesting situation. We'll try and replicate the old behavior. If you increment by 1, it turns into B. But if you increment by 2, it turns into C. And same thing with the lower cases. 1 and 3 will do. Turns into B and D accordingly. If we have it increment that by 1, we replicate the old behavior. If we increment it by 5, we can get 6. We'll also do for 9 not only a 1 to get the next one, but a -1 to go backwards. So we modify our test cases. If we try and run our code right now, we'll get a bunch of failures. Some of them work, some of them don't. The ones that work are the ones I copied and added 1 to, because that's what rotate amount currently does. Same thing as rotate 1. But easy enough to handle. I just need to start using my amount parameter. I replace my 1 with the amount, see how it goes. success. So these were, I've been programming for a long time. These weren't too hard for me. I was able to get through all of them pretty quickly. Now I have my handy rotate amount, which I could use to try and make up some kind of secret code. I could rotate it forwards, and then I could take that letter and rotate it backwards. And you can see I could do some kind of substitution cipher, like they do in cryptography, in order to find a letter rotated a certain number of times and back again sends coded messages. We'll talk more about this kind of stuff later, but for now, just wanted to make sure you had some experience with all these different kinds of functions. Again, it's okay if it didn't make sense. If you didn't understand all the details, come back and rewatch these videos later once you've seen the other lessons. They might all make a bit more sense. Best of luck!